Hello and welcome to the proportional word problems video. I have a problem set up for us where a sun is casting down a shadow and a man and a streetlight, and we need to figure out the height of the streetlight. So let's read this problem out loud to start off with. It states that a man 5.25 feet tall casts a shadow of 6 feet. At the same time of day, a streetlight casts a shadow of 18 feet. How tall, in feet, is the streetlight? So I've drawn a picture of our scenario right here, where we have we'll drag these out to make them a little bit more accurate. Where we have a shadow of 6 feet and a height of 5.25, and here's our little man. And then we have some height in feet for our street light that is casting a shadow of 18 feet. And it's a key part of the problem that we determine that this is happening at the same time of day, because we need the sun to be in the same position in the sky in order to claim that these shadows will be proportional to one another and that these triangles will be similar to one another. If we don't have that information that it's the same time of day, we can't really move forward with solving this problem the way that we're going to, which is by setting up a proportion. So why don't you go ahead and pause the video and see if you can set up the correct proportion so that we can figure out how tall this street light needs to be so that it casts a shadow of 18 feet. So assuming that you've paused the video, I'll go ahead and show the work that I've done, and we can kind of compare this work to yours and see if where you're confused, or maybe you're not confused at all. Okay, so I set up my proportion here, 5.25 feet over 6, meaning 5.25 feet in height will yield a 6 feet shadow. And similarly, x feet in height will yield a shadow of 18 feet long. So we do our cross multiplication and get 6x equals 94.5. And I showed my work for 94.5 over here because it might not be, you might not be able to calculate that in your head, so using a calculator is quite all right. So now we do our division, essentially to find how many groups of 6 feet tall are in 94.5 feet. So 94.5 divided by 6 yields a 15.75 feet in height. So that is claiming that this street lamp needs to be 15.75 feet in order to cast a shadow of 18 feet. And there are multiple ways to do this. I'm showing two of them. And the second way might be a little bit more intuitive, and I actually enjoy it a little bit more than this one, just because the information that you get from the work that you're doing can be beneficial to solve other problems. So it just can kind of do more for you. But there's certainly, I mean, this is a fine way to do the problem. It's correct. And if you're not looking for any more information other than how tall the streetlight is, then solving it this way would probably be the quickest. So a second way, I've copied and pasted so we have the same problem. So what is another way that we can solve this problem? Well, if we think about unit rate, which would be the number of feet in our shadow per every 1 feet in height would be what our unit rate would be showing. How can we use our unit rate to determine how tall this street lamp needs to be? Why don't you take a minute to pause the video again and see if you can determine what the unit rate is, first of all, and how we would use that information to solve for our street light height. So assuming that you've paused the video, I'm going to go ahead and show the work. Now our unit rate here, first of all, we just state our information that 5.25 feet in height, our man's height, yields a shadow of 6 feet. And then I've divided each side by 5.25, right? Because we need 1 feet on this side. We need 1 foot on this side. So you divide by 5.25 feet, and then we do the same over here. 6 divided by 5.25 yields, I think it's actually 1.1428, but I always like to have 2 decimal points in my answer. Therefore, any work I do to get my answer, I usually round to 1 more decimal place, 3 decimal places, just because that way your final answer is more accurate, because calculators and everything will round for you. So we have our unit rate of 1 foot yields approximately a 1.143 foot shadow. So now we take our 18 feet that we know our street light casts in a shadow, and we divide by 1.143. And this is asking how many groups of 1.143 feet are in our 18 feet. And that will tell us how many 1 feet, or how tall our street lamp is. So if we find how many 1.143 feet are in our 18 feet here, like if we kind of saw a bunch of little tick marks that were each length 1.143, each one of those tick marks would correspond with another tick mark on this side, indicating a 1 foot increase in height. So when we do that, when we divide 18 by 1.143, we get 15.75, which again was the same height that we got on the previous page. And the reason for me saying that I preferred this way, or I like the information that it gives us, is because now that we know 1 feet, what 1 feet in height yields as a shadow, we can find any shadow length, we can have any shadow length and know the height of the object that caused that shadow. So that's why this is kind of so cool, not even just in these type of proportion problems, but any type of ratio or proportion problems. Finding the unit rate can be so time saving if the problem wants you to carry on and find multiple lengths, heights, whatever your ratio is calling for. So again, both of these problems yielded the same answer. They're both 15.75 for our streetlight. Again, it's just whatever you prefer, however you prefer to carry out the problem.